Okay, so we had no homework on Friday, so I'm just going to pick up from where we left off, which was our 10th theorem, and it was the first circle theorem. It's actually the only one we're going to do for now because it's the only one on the ordinary level course. So I'm coming back to geometry. I think it might be the start of the third year, and we'll kind of recap all the theorems we've done between May and now, and I'll give you the rest of the circle theorems. I don't think there might be one additional triangle theorem, and then there's a few, there's maybe 4 or 5 circle theorems, but it'll be a good opportunity to kind of recap everything. So anyway, each angle in a semicircle is a right angle, okay? It's kind of a weird way of saying it. Essentially what you need is, you need a circle, okay, because it mentions semicircle, and the base of the triangle has to be the diameter, okay, because that's how you get your semicircle. Okay, so that's the diameter that cuts the circle in half. So from there, if you create a triangle, and it doesn't matter, sorry, none of these lines are going to be straight, but it doesn't matter what triangle you create, the angle at the top here, just like this one, okay, so the angle at the top up near the circumference will always be a 90-degree angle. Okay, so that's the theorem. So I have a couple of questions snipped out of the book here, so we'll have a look at this. So the diagram shows a circle with centre O, and we need to find angle A and angle B. Okay, so the centre is O, which means this line here goes from circumference to circumference and it passes through the centre. That makes that line a diameter. And the fact that that line is a diameter, that means it's cutting the circle into 2 semicircles. Okay, so what I have here is a triangle inside a semicircle, which means by my theorem, I know that that angle there has to be 90 degrees. Okay, there's the base. So the angle at the circumference, the one not touching the diameter, is 90 degrees. Okay, so I would say the size of angle A is equal to 90 degrees. And how do I know? The way we name this term is just angle in a semicircle. Okay, so the angle in a semicircle is 90 degrees. Then it's kind of irrelevant. Once you've got that, it's irrelevant that you have a circle around it. You still have a triangle. So we know that the 3 angles of a triangle add up to 180. So 40 plus 90 is 130. 180 minus 130. What's wrong with that? 130 is 50. And how did I know that? This thing is 3 angles in a triangle equal 180. That's how I knew. Okay, so we know that angle B is equal to 50. Is that okay? That's the first one. Next one. The diagram shows various chords in a circle. Identify the diameter of the given circle. Okay, so there's loads of lines. So there's the line AC, there's the line BC, there's the line AB, there's DE, there's EF, and there's DF. Okay, so there's 6 lines inside that circle. They all go circumference to circumference, so they're all chords, but they are telling us that one of them is a special chord, a diameter, and the diameter, the one that cuts through the center. Okay, and we need to figure out which one of these 6 chords is actually a diameter. Okay, so if we look here to start with, see here, that angle there up at the circumference is 80 degrees. Now we know that if the base of the triangle is a diameter, then this angle will be 90 degrees. The fact that that's only 80 means that is not a diameter. Okay, but if we look at the other one, the angle here at F, the angle EFD, is 90 degrees, And the fact that you have a 90-degree angle here means that this line has to be a diameter. So identify the diameter. The diameter is DE. And how do we know? We know because angle DFE is equal to 90 degrees. So the angle in a semicircle equals 90 degrees. Okay, so the next one then, there's a right angle triangle, ABC, constructed in a circle as shown. Identify what line segment the center of the circle lies on. Okay, so again, this is 90 up here. That means the base of that triangle must be a diameter. So AC is the diameter. Okay, and we know that because of where the 90-degree angle is. Okay. Next it says, using the theorem of Pythagoras, find the length of the diameter of the given circle. Okay, so we'll identify there's your right angle, so opposite your right angle is the hypotenuse. Like the questions before, it doesn't matter which of these two, so we call this one the opposite and this one the adjacent. And then just to link it with the, sorry, change my colours. Just to link it with the formula and tables book, this is C, this is A, and this is B. Alright, so we have C squared equals A squared plus B squared. So C squared equals 3.5 squared plus 1.2 squared. 3.5 squared is 12.25 and 1.2 squared is 1.44. So add those two together and we get 13.69. And then to get rid of the squared, we do a square root. So C is the square root of that, which is 3.7. The units in the question is meters, so it's 3.7 meters. Okay, and that makes sense. It's kind of always good to look back and check if the answer you're after getting makes any sense. We know that the hypotenuse should be the longest side. So we've 1.2, 3.5, and we're after working out that the hypotenuse is 3.7. Okay, so that's that one. Right, so that's pretty much it in this chapter. So they do some things with theorem terms and stuff like that, like they're just definitions really. But I'm not going to worry about them until I'm doing the constructions with you, and I'm going to leave all of them until about 3 weeks before your junior cert. It's the best time to do it. You just do it and then it kind of stays fresh in your memory. So what I'm going to do is I'm going to pick an assortment of questions from the revision exercise. So we'll kind of cover the whole chapter, and I'm also going to pick a couple of questions from the revision exercise in the higher level book. Okay, so I'll put together a few questions. I was going to get you to do like, kind of a chunk of these in class and then whatever you didn't finish for homework. So that's what we'll do. So, I mean, this is only taking about 8 or 9 minutes to get through those examples. So providing you're okay with the examples, obviously pause it as you need and take down your notes. As soon as you've done that, start into this. And I'll start with the ordinary level questions and then into the higher level questions. Okay, so hopefully with the ordinary level ones, you'll kind of get used to what you're doing and then move into the higher level ones. Okay.